So we need to use the definition of a Taylor series to find the first four non-zero terms of the Taylor series for the given function centered at A. We also need to write the power series using summation notation. Well, now let's write the Taylor series formula with center A. F of x equals f of a plus f prime of a over 1 factorial times x minus a, plus the second order derivative of f of a over 2 factorial times x minus a squared, plus the third order derivative of f of a over 3 factorial times x minus a cubed, and so on. Here f of x equals ln of x and a equals 3. So let's find the derivatives of f of x. So f of x equals ln of x. F prime of x equals 1 over x. The second order derivative of f of x equals negative 1 over x squared. And the third order derivative of f of x equals 2 over x cubed. Now let's find the values at x equals 3. So f of 3 equals ln of 3. F prime of 3 equals 1 over 3. The second order derivative of f of 3 equals negative 1 over 9. And the third order derivative of f of 3 equals 2 over 27. Now we will substitute the values and we get that f of x equals ln of 3 plus 1 over 3 over 1 factorial times x minus 3 plus negative 1 over 9 over 2 factorial times x minus 3 squared plus 2 over 27 over 3 factorial times x minus 3 cubed and so on. Let's simplify. This equals ln of 3 plus 1 over 3 times x minus 3 minus 1 over 18 times x minus 3 squared plus 1 over 81 times x minus 3 cubed. And so on. So the Taylor series with first non-zero terms with center A equals 3 is this expression. Now we need to represent it in summation notation form. This equals ln of 3 plus sum of from n equals 1 to infinity of negative 1 to the power of n plus 1 times x minus 3 to the power of n